Bismillah ar-Rahman ar-Rahim. We'll continue. Now we finish the quotient rule. Now we'll do the derivative of these trigonometric functions, which is derivative of tan is secant square, cotan minus cosecant square, secant times tan, secant x tan x, cosecant minus cosecant x cotan x. So I need to use these formulas to find the derivative. So it will be the derivative here, y prime, derivative of x is 1, derivative of tan is secant square. That's it. Here I have product rule. So derivative of the first is 1 times the second plus the first derivative of secant. What's the derivative of secant? Secant tan, secant x tan x. That's it. Yeah, this one actually we can do it in 3.2, but it's okay. So y prime will be 2x times sine x plus x squared cosine x. Derivative of the first times the second, this is the first times derivative of the second. Now, let me do these problems. First one, actually this can be done with, some of them we can do it with, what do you call it, 3.2. Okay, first one, or no, I need the product rule here. So y prime, derivative of the first, it will be x, derivative of x, which is 1, sine x, plus x cosine x. What's the derivative of cosine? Minus sine x. So the answer is x cosine x. 2. Y prime will be what? Derivative of the first, which is 1 times cotangent x, minus or plus. What's the derivative of cotangent? Minus cosecant square. Don't forget, the derivative of cotangent is minus cosecant square. That's it. That will be the answer. Cotangent x minus x cosecant square x. 3. I have product of two functions, so it will be ax, the second, derivative of the first, which is ax, times the second, plus derivative of the ax, which is the first, and derivative of the second, which is cosine x. So it will be ax sine plus cosine. Okay, number 4. Yeah, it's the quotient rule now. Y prime. Let me do number 5, then I will do 4 here, in this space. Y prime will be what? Minus 2 cosecant. What's the derivative of cosecant? Minus cosecant cotangent, because of that I put a minus with the 2. So this minus cosecant cotangent x plus or minus 5 sine x. The derivative of cosine is minus sine x. Yeah, that's it. Okay, let me do number 4. So I have quotient rule. Derivative of the numerator, cosine x, times the denominator, minus derivative of the denominator, which is, or let me sine x, derivative of 1 plus cosine x, which is minus sine x, over 1 plus cosine x all square. That give me what? Cosine x plus cosine square plus sine square over 1 plus cosine x all square. That is 1 plus cosine x is 1. So 1 plus cosine x cancelled with this one. I have 1 over 1 plus cosine x. Yeah. Number 6, the idea, sometimes you can simplify the function, then you can do the derivative. So look at this. Tan x minus x over secant x. This is what? The function. Huh? It will be sine x over cosine x minus 1 over 1 over cosine x. So that gives me sine x minus cosine x over cosine x over 1 over cosine x. So this is cancelled. So I have sine minus cosine. Now the derivative will be easily, can find the derivative as cosine minus plus sine. Yeah. Oops. Is it? Yeah. Sine is cosine, minus cosine is minus sine, which is plus. The idea is sometimes you can simplify the function and then find the derivative. More questions. Now we have to find the equation with tangent line. What will be the slope? It will be y prime at pi over 4. So what is y prime? It will be secant square x. So it will be the slope. The slope will be secant square at pi over 4, which is what? 1 over square root of 2 all square. That the cosine reciprocal, that will give me 2. Square root of 2 all square, which is 2. So the equation will be y minus 1 2x minus pi over 4. In other words, y will be 2x plus 1 minus pi over 2. Yeah. Differentiate this. Find what values does the graph have horizontal tangent. Horizontal tangent means f prime equals 0. What is f prime? Can I simplify it? Will that make a difference? I'm not sure. So let me do f prime. It will make it easier with sine and cosine, but it's okay. Let us do it. Now, yeah, let me do f prime here. F prime of x. Derivative of numerator, secant times tan times the denominator minus the numerator. Now, what's the derivative of this? Is secant square x all over 1 plus tan x all square. Now, I can take secant common factor. What's the remaining? I have tan x plus tan square minus secant square all over 1 plus tan x all square. Yeah. Yes, tan x plus tan square minus secant square. Yeah, don't forget 1 plus tan square equals secant square. So secant square minus tan square will be 1. But tan square minus secant square, this is minus 1. So that will be secant x tan x minus 1 over this whole square. If I make it equal to 0, I have two cases. Secant x equals 0 or tan x equal 1 or tan x equal 1. This is impossible. As we know, secant is 1 over cosine, and secant should be either greater than 1 or less than minus 1. Cannot be equal to 0. When tan x equal 1, when x equal pi over 4 plus n pi, where n, yeah, it's pi over 4, pi over 4, yeah, 9 pi over 4, and so on. Okay. Because tan is positive in the first and the third quadrant. Okay, so that will be the answer. Okay, let me do all the exams questions quickly. What will be y prime? Just do the derivative minus ax plus secant square x. Yeah, quick one. So y prime at 0, substitute minus 1. What is secant? 0 is 1, so that will be 0. So this is the answer. Quick questions. Cotan times cosecant, I have product rule. So what's the derivative of cotan? Don't forget that will be minus cosecant square times cosecant plus cotan times derivative of this, which is minus cosecant cotan. Oops. So that give me what? Minus cosecant cubed minus cosecant x cotan square x. Yeah, I want to do it. I know that cosecant x, cosecant pi over 4 is what? Square root of 2. Yeah. So do it. I have f prime at pi over 4, and cotan pi over 4 is 1. So that give me what? Minus square root of 2 cubes minus square root of 2 times 1. So that will be what? This is what? Minus 2 root 2, because I have square root of, yeah, you can think of it this way. The square root of 2 squared times square root of 2. Yeah, so that will be minus 2 root 2 minus root 2. So the answer is minus 3 root 2. Yeah, I can do it in your way of calculation. Tan x minus 1 over secant x, we did it here. Yeah, number 6, where function is sine x minus cosine x. So the function is sine x minus cosine x. So what is y prime? It will be cosine x plus sine x. What they want? They want y prime at pi over 4 to be square root 2 over 2 plus square root 2 over 2, and that gives me square root of 2. That will be the answer. E to the power x secant, what will be y prime? Product rule, e to the power x times secant x plus e to the power x secant tan x. Okay. I can take e to the power x and secant x common factor. I have what? 1 plus tan x. Notice something. This is what? This is y. So this is y, 1 plus tan x. So he stated in terms of y. Yeah, nothing to. Just a calculation. This is, we are back to this limit. X goes to a, f of x minus f of a over x minus a is f prime at a. But this is, they make it, the function is this. And notice a is what? A is pi over 6. Where if I do f of pi over 6, you get what? 1 plus cosecant pi over 6 over 1 minus cosecant pi over 6. Sine pi over 6 is half because cosecant is 2 over 1 plus 2 over 1 minus 2. That will be minus 3. So this limit, I can write it as limit x goes to pi over 6. This function minus 3. So it will be limit x goes to pi over 6, f of x minus f of pi over 6 over x minus pi over 6. So this is will be f prime at pi over 6. Yeah. I think this is a too lengthy problem. Okay. So I have the function is 1 plus cosecant x over 1 minus cosecant x. I need to find f prime at over 6. So let me find the derivative first. That will be what? Derivative numerator. That is minus cosecant cotan times the denominator minus. This is cosecant cotan times the numerator. All over the denominator square. Yeah. Now I need to do this. Yeah, let me do the calculation, simplify it. That will be minus cosecant cotan plus cosecant square cotan x minus cosecant cotan minus cosecant square x cotan x over this. Yeah, this seems to be cancelled, gone. So I have minus 2 cosecant cotan x over this. This is f prime. And I want f prime at pi over 6. Yeah, don't forget cosecant pi over 6 is 2. And I need cotan also. Cotan pi over 6 will be what? Square root of 3. Yeah. So plug the numbers. Have what? Minus 2 times 2 times square root of 3 over 1 minus 2 square. So the answer is minus 4 square root of 3. Yeah, that will be the answer. This is the idea where he linked the limit, think of it backward, link it with the definition to find the derivative, and then the calculation. Calculation is a little bit. Yeah. The slope of the tangent line. Slope of tangent line will be what? Y prime at 0. Find y prime. To use the formulas. Derivative of secant, that will be secant tan. Correct. Times the numerator. Minus derivative of this, which is minus secant square x. P1 times secant x over this square. The slope is y prime at 0. Tan 0 is 0, so that will be 0. Here I have what? Plus 1 times 1 plus 1. Secant 0 is 1. I have 1 minus 0 square. So the answer is 2. Yeah. This is over tangent line. The same question. No, it's 1 over 1 minus secant. Who cares? Okay, let me do the calculation. So the slope will be y prime at pi over 3. That's the slope. Okay, to find y prime, that will be secant tan times 1 minus secant minus secant plus, it will be plus secant x tan x. There's a minus sign here, times 1 plus secant x over 1 minus secant x all square. Okay, now secant pi over 3, it will be 2, and tan pi over 3, it will be what? Tan pi over 3, it will be sine pi over 3 square root 3 over 2, which over half, that will be square root of 3. So that y prime at pi over 3, which is the slope, will be what? Secant pi over, that will be 2 square root of 3, 1 minus 2, okay, plus 2 square root of 3 plus 2 over 1 minus 2 square. So that give me what? Minus 2 root 3. Here I have what? Plus 6 root 3 over 1. That will be 4 root 3, which is this. The graph has a horizontal tangent at what? He put this. Huh? We did something similar. We did that. The same problem. I think we did it before. Yeah, here. Where we get, it's at pi over 4 plus n pi. But since he put this, so it's only at x equal pi over 4. I just need to find f prime, make it equal 0, try to solve it. Okay, then I move to the higher order derivatives. Now, this is the notations. Huh? This is the first derivative, y prime, f prime, dy over x, y double prime, f double prime. This is the way they write it as Leibniz notation. And this is the third, and so on. Okay, we know this from 3.2. If you have x to the power n, what's the n derivative? It's n factorial, and any more derivative will be 0. Okay, using the pattern. Huh? Now, let me check this one, function x e to the power x. What will happen to the n derivative using the product rule? So I have f prime. It will be what? Derivative of the first, ax plus x ax. If you notice, this is 1 plus x ax. Second derivative, that will be derivative of this, which is 1 times the second times the 1 plus x, derivative of this, e to the power x, which is 2 plus x, e to the power x. The third, if you do the calculation, you get what? 3 plus x, e to the power x. So it will be the n derivative that will be n plus x e to the power x. That will be the end derivative. Let me go to cosine and sine. Cosine, what will happen? Actually, we did it in 3.2. F prime would be what? Minus sine. F double prime, it will be minus cosine. The third is what? Sine. And the fourth is cosine. So what will happen? Every 4, I'm coming back. This is starting with cosine, and the fourth derivative, I'm getting to the cosine. So every 4, it will repeat itself. So what I will do, I will look at this 27, and it find you want to find the 27 derivative. I will do 27, since it's 4, it will repeat itself by 4. That will be 6, 24, 3. So this is the same as the third derivative, which is sine x. That's the idea. Let me do now all the exams questions quickly. He wants the third derivative, where I can't do it in calculation. F prime would be 3x squared plus sine x plus 2 cosine x. Yeah, 3x squared cosine, yeah, plus 2 cosine x. Second derivative. Since it's the third, so we can do it quickly. That will be 6x plus cosine x minus 2 sine x. The third derivative, that will be 6 minus sine x minus 2 cosine x. Now what they want the third at 0. That will be 6. Sine 0 is 0. And this is minus 2. So the answer is 4. Calculation. The third derivative, let me do it. F prime will be what? Sine t plus t cosine t. Product rule, just apply the product rule. Do it again, second derivative. Then third, let me do the third, all the 3 derivatives. That will be cosine t. Here I have what? Cosine t minus t sine t. Huh? I'm doing the product rule here. So this is what? 2 cosine t minus t sine t. Now let me do the third derivative, which I'm looking for. Be careful. This will be minus 2 sine t. This is now product rule. Don't forget multiplying by minus sine t minus t cosine t. So the answer is minus t cosine t minus 3 sine t, which is this one. Minus x e to the power x. He wants the 51 derivative. If you remember, forget about the minus. We did this. It will be x plus n. So for the f prime, I have the n derivative. The minus will do nothing. Huh? It will be minus x plus n e to the power x. So what he wants, the 51 derivative, that will be minus, I have the n51, x plus 51 e to the power x. What they want this at 1. That will be minus 52 e to the power 1, which is e. So that will be the answer. Now this is quotient. Let me do it as a quotient. Actually, with the chain rule, it will be better, but let me do it as a quotient. See what will happen. F prime. F prime will be what? Derivative of the first numerator times the denominator minus x e to the power x over ax all square. So it will be 1 minus x ax over ax squared. In other words, 1 minus x over ax. Let me check the second derivative. Derivative of this, minus 1 ax minus 1 minus x ax over ax square. So what will happen in the numerator? I have minus x. That will be x minus 2. E to the power x cancel with 1 of e to the power x, so that over e to the power x. Third derivative. That will be what? ax minus x minus 2 ax over ax square. That will be 3 minus x ax. No need for ax since I cancelled with one of these ax. So the fourth derivative, if you notice, this is 1 minus x, this is x minus 2, this is 3 minus x, so I'm expecting this x minus 4. What I need, the 100 first derivative, odd, the odd is the number minus x, the even, x minus the number. So I have this 101 minus x over e to the power x. What they want this at 6. So it will be 101 minus 6 over e to the power 6, which is 95 e to the power minus 6, which is this one. Yeah. Sine x cosine x, you want the 2019. Yeah. Okay. So what will happen? Yeah, let me do the first derivative. That will be cosine minus sine. The second derivative, that will be minus sine minus cosine. The third derivative, that will be what? Yeah, minus cosine plus sine. The fourth derivative, here is the catch, it will be sine plus cosine, which is what? The same thing. So every 4, it will repeat itself. So I need to check this. 2019 over 4. If you do the calculation, you get remaining 3. So this one is the same as the third derivative at pi. This one, if you do the calculation, the remaining is 0. So it will be like the f of x, f of pi. So what is the third derivative? Let me do this. The 2019 at x minus f 2020 at x, that will be the same as the third derivative. The fourth or the first is the same, huh? Minus f of x. So that implies this one will be equal the third at pi minus the function at pi. What is the third at pi? I'll substitute here. That will be what? Minus cosine pi plus sine pi minus, yeah, this one equal, let me be sure, minus cosine pi plus sine pi minus f of pi sine pi plus cosine pi. Cosine pi is minus 1. So that will be 1 plus 0, 1. This is minus 1. So the answer is 2. That would be the answer. Yeah. Yeah. He gave me the second derivative. And he wants the 8th derivative. So, yeah. Second is minus sine x. Third is minus cosine. Fourth is sine. Fifth is cosine. Sixth is minus sine. First, this will be the 7th. And that will be the 8th. Because it will repeat itself. So, what will be the 8th at x? At pi over 2, at pi over 2. That will be sine pi over 2, which is 1. So that will be the answer. Yeah. Let me stop the recording. Yeah. The remaining, I think, is only the questions from the book. I will do it later. So let me stop the recording. Thank you.